Hello everyone, something a little different this time for a video. This is part of your last experiment, household acids and bases experiment. I'll just hold this up real quick. So, you should have this downloaded and ready to go. Okay, what we're going to do, we're going to measure the pH of some solutions which have been left blank there. Okay, so I got some vinegar, which is here. I've got some detergent, and I got a soft drink. Okay, I've also got just some water out of the tap, which I'm going to use to rinse the pH probe. And yes, as a nerdy chemist, I actually own my own pH probe. Okay, so this is actually taking place in my house. I just ran and got this from my basement. Okay, so you would do something like this in your lab, very similarly, but I'm just going to show you just a few from your list in the house here. So what I'm going to do, first thing I'm going to rinse off the probe here. Okay, give it a quick dap dry. You would do this in lab too. Okay, so I'm going to test various things and then just rinse it off a little bit. Okay, first one, it's sparkling water, and I think I mentioned in a previous lecture that the acidity of soft drinks comes from the fact that there's usually a lot of carbon dioxide dissolved. If there's this fruity drink, often citric acid too. But I want to show you kind of a point here, okay? It's the carbonation that causes the pH to be the way it is, okay? So I've just poured in some carbonated water, all right? And I'm going to measure the pH, all right? So I'll try and bring that to camera, take a look. Can you see the number? Let's wiggle it around a little bit. It's settling on 4.1. Let's wiggle it around a little bit. There, 4.1. So the pH of a soft drink, or just sparkling water in this case, is 4.1. Okay, so we can fill that in. Take your chart, soft drink, 4.1. Okay, next one. And again, I just rinsed it off there. Okay, it's returning down to kind of a more neutral pH. Remember, pH runs, 7 is neutral, acidic is between 6 and 1. So, yep, it was an acidic soft drink, okay. And then basic is between 8 and 14. Now I have a prediction. This is vinegar, okay. Fish and chip vinegar, obviously, because I'm a stereotype. Okay, so you think vinegar is acidic? Do you think about it? It tastes sour, right? So that sour taste is acidity. Okay, if you think about it, going back to the sparkling water does taste a little bit tart, doesn't it? The fact that your soda tastes sweet is the 14 teaspoons of sugar per can that kind of gets you to taste the sweet, not the sour. Okay, anyway, back to it. So let's check the vinegar. Okay, in we go. Take a peek. Well, look at that. Swish it around a little bit. Vinegar has a pH of around 2.8. Let's make sure you can see that. There we go, 2.8. All right, write it in the column there. Vinegar, around the top there. Vinegar, 2.8. All right, so I'm going to swizz it around in just regular tap water just to kind of clean it off a little bit. All right. My tap water from my house is a very slightly acidic pH. That's probably because there's CO2 dissolved from the air in the water. Okay. All right. Last but not least, we have our super deluxe dish soap. Okay, so I just dissolved a little bit of dish soap in the cup here. You can see the soap around the top there. Throw it on in there. If you can see, get it so the light can just catch it. 8.4, 8.5, give it a swizz. 8.7, 8.8, let it settle. Looks like 8.8. Okay, so dish soap, 8.8. All right, so filling the remaining section of the chart, dish soap 8.8. That's the 3 I have in the house. Obviously, if you were to do this at school, you'd have access to the others, but special time school for special measures, right? So let's stop there. Obviously, you're watching this now. This should be watched before you complete the lab, okay? Because the pre-lab, which you'll look at next, will have some useful theory you need to finish this experiment. Okay, let's stop there.